In this session, I'll be talking about multiple regression and logistic regression. At the end of this module, be able to determine if and how multiple inputs affect a continuous response where the input variables are continuous. Determine if and how multiple inputs affect a continuous response where the input variables are continuous and discrete. And then finally determine if how multiple inputs affect a binary or nominal response. Where does this analysis fit in the overall picture? Well, as shown under the analyze phase, we would need to do hypothesis testing, and one of the possibilities for conducting hypothesis testing is regression analyses in various forms. The drill down of the analyze phase, it leads us to hypothesis testing. We drill down from that, we lead to our decision tree. In that, we'll see binary logistic regression, ordinal logistic regression, nominal logistic regression, and basic regression also, where we're going to be looking at the output of a response and have the inputs that could be continuous, or they might even be categorical. So we want to start with a 30,000 foot level chart. We're not going to do anything if the 30,000 foot level chart is giving a prediction that's satisfactory, but if it's not, then that metric pulls for the project creation. We want to then build hypothesis using the data from the recent region of stability, which could be 3 days, 3 months, or 3 years. Wisdom of the organization thoughts can give us, help us with directions, what we might do for various hypotheses that we want to look at. We can also do a statistical quantification of the benefit from an actual improvement project using these techniques. So where we're looking at focusing again is the 30,000 foot level chart. We then look at how it's performing relative to our needs, and if it's not satisfactory, then it pulls for project creation. We then want to focus on what we could do to improve this metric, and then so we improved it like that. So now we look at the percentage of non-conformance after the completion. And hopefully now we've got a lesser number and we can translate that to bottom line benefits. So another way of looking at this response is we've got a continuous response, 30,000 foot level, and then we look at our processes and there's an input that impacts our process output. So if we understand that and there's a good correlation, then maybe we control that input. But we can get some insight to what we might do to improve our process with this understanding. So when we have multiple regression, we got several factors and inputs, and they're each going to have their relationship slope that would be like B1, B2, and so on. Now, one thing we need to be aware of, there can be multicollinearity where it indicates that the inputs are actually correlated to each other, which is not good. That affects our prediction equation. So we want to address that in our analysis and what we're actually doing along the way. Now, another technique that we have involved in this is general linear model. General linear models can analyze effect from simultaneous effects of multiple variables, including mixtures of categorical and continuous input variables. Logistic regression can take several different forms. If the output is pass or fail, then we want to determine what could be causing that, then binary logistic regression. So for example, our 30,000 foot level chart is nonconformance rates, and then we want to determine what impacts that nonconformance rates, and we're looking at various temperatures, or we're looking at pressures, or we could have suppliers. Notice I got discrete and I got continuous inputs. Then we'd use binary logistic regression. Now, ordinal logistic is applicable when the response is ordinal. So there's a natural ordering of categories, but the distance between the categories is not known. That describes exactly what happens in surveys when you've got a Likert scale of 1 to 5. So you've got 5 as maybe the best and 1 is the worst. So say we've got a bunch of survey questions in a random sample, and we want to figure out where what's impacting the overall evaluation. So what if you can do is get the inputs variable, like can be discrete or continuous, and then you can run an ordinal logistic regression equation to find out if there's some input drivers that you hypothesize that really make a difference in the overall survey response. Nominal logistic regression is applicable whenever the response is nominal. That is, there's response differentiates between items, but based upon their names, such as type of defects. So let's say, for example, we've got the Pareto chart of different types of defects, and we want to better understand what's driving those defects. So we can look at inputs, could be temperature, pressures of suppliers or whatever, and we want to see which one significantly impacts that overall regression response. So if that's the case, then nominal logistic regression is applicable for the situation. So in summary, we talked about how to determine if multiple inputs affect a continuous output response, where the input variables are continuous. We talked about determine how the multiple inputs affect a continuous response, where the input variables are continuous and discrete, and then determine how multiple impacts affect a binary or ordinal or nominal logistic response.